Welcome to Maths Academy Tube. Here is everything that you need to know about vectors and transformation of the plane. In this video, you will get some selected problems on vectors, translations, reflections, and rotations. So these are the point of discussion under this unit. So this video lesson is very helpful for grade 11 and 12 natural science students. So stay with me. The first question is about vector. Which of the following is a vector? Which of the following is a vector that lies on the line through 0, 0 and 2, 4? So we are asked which of these given vectors are vectors lying on the line through 0, 0 and 2, 4. First of all, the line passing through 0, 0 and 2, 4 should be known. So to determine the line passing through these 2 points, the first thing we calculate the slope. Slope is equals to change in y over change in x. Okay, so change in y means you will have 2y values, y2 minus y1 over x2 minus x1. So you can say this is x1, y1, say this is x2, y2. So y2 minus y1 means 4 minus 0, which is 4. x2 minus x1 means 2 minus 0, which is 2. Therefore, the slope of this line passing through the 0, 0 and 2, 4 is 2. So the equation of the line becomes y is equals to mx plus b. Now m is known, so the line becomes 2x plus b. To determine the value of b, you can take one of the points. So let's substitute 0, 0 in this equation. Use 0 in place of y and 0 in place of x. Then 0 is equals to 2 times 0 is 0 plus b. So b will be 0. Therefore, the equation of a line passing through 0, 0 and 2, 4 is y is equals to 2x. This is the equation of the line. So every point on this line, will have this form, k 2k, or let me take some points, give some values for x. If x is given by a certain number k, where k is an element of real number, the value of y becomes 2 times x, which is 2k. Therefore, every point on this line will have this form. K 2k is a point on the line. Okay, this is a point on the line. Now, if this is a point on the line, we can determine the vectors on the line. For example, let's take the choice in A. If u is 2, if the first entry is 2, the second entry will be 4. Okay, so A cannot be the answer. If we take B, in B, if x is minus 2, the value of y becomes minus 4. Okay, B will not be the answer. A cannot be the answer. B will not be the answer. Let's check for C. If I take 1 over 2 in place of k, then take 1 over 2, then the second entry becomes 2 times k, which is 2 times 1 over 2, which is 1 over 2 comma 1. Still, C cannot be the answer. Again, let's check for D. In D, we have minus 1 comma minus 2. Normally, whenever k is minus 1, if you substitute k to k, if k is minus 1, definitely y becomes 2 times k, which is minus 2. Therefore, minus 1 comma minus 2 is a vector on the line L. So our answer for this problem will be D. If U is a vector with component -3, x, and V is a vector with component x, y -2, if we have these two vectors, what is the value of y so that the vectors will satisfy this condition? That means we are asking the value of y satisfying the condition u plus v is 3u minus 1/2v. So let us write the given information as it is, given the vector u and v, given u is -3, x, and v is x, y -2. This is the given thing. Then we are asking the value of y satisfying the condition u plus v is equals to 3u minus half of v. Now we will substitute everything in this condition. So in place of u use -3, x, and v is x, y -2. This is 3 times u, which is -3, x, minus half of v, x, y -2. So we need to carefully distribute the given coefficients into the entries. Then, using the principle of vector addition, we use addition component-wise. We add -3 with x, so it becomes -3 plus x. Okay, -3 plus x will be the first entry. -3 plus x will be the first entry. Then the second entry will be obtained by adding x with y -2. So add x with y -2. Okay, this is the sum of the vectors on the left hand side. Then multiply every entries by 3, then you will get -9, 3x, minus, multiply this 1/2 into the entries, it becomes x/2, then y/2 minus 1. Now we take the difference between these two vectors. So the left hand side will remain as it is, x -3 plus x, x plus y -2 will remain as it is, and we take the difference between these two vectors. Okay, so -9 minus x/2, again take the difference between 3x and y -2. So subtract y -2 from 3x, y -2 minus 1 from 3x, then this becomes here -9 minus x/2, 3x minus y/2 plus 1. So these two vectors are the same, -3 plus x, x plus y -2, and this part are the same. Now, from the equality of two vectors which are given in component form will be equal if their corresponding entries are the same. That means -3 plus x must be the same as -9 minus x/2. So from here, -3 plus x must be the same as -9 minus x/2. At the same time, their second entries, x plus y -2 must be the same as 3x minus y/2 plus 1. So x plus y -2 is the same as 3x minus y/2 plus 1. Now you can collect like terms. Okay, by collecting like terms, we will get -3 plus 9. This 9 will be taken to the left, and it becomes -9 will become plus Then on the right side, minus x over 2 minus x, and x minus 3x is equals to minus y over 2 minus y plus 3. Okay, you can take the minus to the right, and you can take this minus 3x to the left, it becomes minus 3. So here you can do collecting like terms, nothing more. So from the first part, you can get the value of x. Minus 3 plus 9 is 6. 6 is equals to minus 3 over 2x, because here minus x over 2 minus x means minus 3 over 2x. So multiplying both sides by 2, 12 is equals to minus 3x. Dividing both sides by minus 3, then you will get the value of x from the first part. 12 over minus 3 is minus 4. So minus 4 is the value of x. Now we substitute this minus 4 here. We will substitute it here. Okay, so from this part, we do have x minus 3x is equals to minus y over 2 minus y plus 3 means minus 2x. Minus 2x is equals to minus 3 over 2y plus 3. But here x is minus 4. So substitute in place of x, substitute minus 4. This is equals to minus 3 over 2y plus 3. Minus 2 times minus 4 is 8. 8 is equals to minus 3 over 2y plus 3. Now take this 3 to the left side. 8 minus 3 is equals to minus 3 over 2y. 8 minus 3 means minus 5. I mean positive 5 is equals to minus 3 over 2y. Again, multiply both sides by 2. It becomes 10 is equals to minus 3y. Now dividing both sides by minus 3 by minus 3. Then the value of y becomes minus 10 over 3. This is the required answer. Okay, this is the required answer. The value of y is minus 10 over 3. That make the given condition here equal. So from the choice, our answer will be B. If vector A and B are perpendicular, if A is perpendicular to B, what is the cosine of the angle between A and A minus B? Here we will apply the rules of vectors and some of the formulas related with vectors. So it's given that A is perpendicular to B. So mathematically, if two vectors are perpendicular, their dot product is 0. The dot product of the two vectors will be 0. This is the mathematical interpretation of perpendicular vectors. The other thing is, if we have two vectors A and B, the dot product of A and B is defined as the norm of A, or the magnitude of A times the magnitude of B times cosine of the included angle. This theta is the angle between the two vectors. Now let me take you back to the question. The question is, we are asked the cosine of the angle between A and A minus B. You can consider this A minus B as a single vector. So we will use this formula. Now A dot, the dot product of A with A minus B is defined as, according to this definition, the dot product of A with A minus B is defined as the magnitude of vector A times the magnitude of A minus B times cosine of the included angle. This theta is the angle between A and A minus B. So this means A dot A means, let me write it as it is, A dot A minus A dot B. You can use distribution, okay? Dot product is, there is a distributive property on the dot product. This is the same as the norm, or the magnitude of A times the magnitude of A minus B times cosine of the included angle. Now there is one fact regarding dot product of any vector with itself is the squared value of its magnitude. So this is true. So in place of A dot A, we can use the norm of the square of their norm. So the squared value of the norm of A minus A dot B is 0 because it is given that the two vectors are perpendicular. Minus 0 is equals to the norm of A times the norm of A minus B, the norm of A minus B times cos theta. So now we can divide both sides by A, norm of A times norm of A minus B, okay, over norm of A times norm of A minus B. Okay, so cosine of the angle between the two vectors is, it becomes norm of A square, norm of A square over norm of A times norm of A minus B. Norm means magnitude. Now you can simplify this A by, here you have A square, so you can simplify it. Therefore, the cosine of the angle between the two vectors is the norm of A over the norm of A minus B. The norm of A minus B. So this is the required answer. So the answer will be A. Which of the following is necessarily true? So it's about vector. We will identify a necessarily true statement from this alternatives. If we see the first one, vector A, if we see the first one in choice A, if vector A, if the magnitude of vector A and B are equal, this doesn't mean that the two vectors are equal. This is not necessarily mean that the two vectors are equal. For example, you can take vector A as 3i plus 4j. Obviously, the magnitude of this vector is 5. And you can also consider vector B as, you can consider vector B as minus 4i plus 3j. Still, the magnitude of vector B is, the magnitude of vector B is also 5. But these two vectors are not the same. Okay, the magnitude of the two vectors is the same doesn't mean that the two vectors are the same. Therefore, A is wrong. Let's check for B. If U is a unit vector in the direction of A, then A dot U is a norm of A. Let's check for the statement in B. If U is a unit vector in the direction of A, then U will be defined as the vector A over the magnitude of vector A. This is what we mean by a unit vector in the direction of A. Now let's check a dot, the dot product of vector A with U. That means the dot product of vector A with U is a dot, I mean vector A over norm of A. So this means A dot A means the squared value of the vector, the norm of vector A over norm of vector A. Then this is simplified to vector A. Okay, so if U is a unit vector in the direction of vector A dot U is the same as the magnitude of vector A. This is always true. So B can be a necessarily true statement. So we can check that the rest are wrong. So for example, if we take the statement in C, the magnitude of K times vector A is K times vector A. It says like this. This fails whenever K is negative. If you take K is negative, this statement will be wrong for any negative K values. So C cannot be a true statement. C will be true only whenever K is positive. Otherwise, for any real number, it's wrong. Let's check for the statement in D. In D, if A is parallel to B, then A dot B is 0. This is wrong. This statement will be true if A is perpendicular to B. If A is perpendicular to B, then A dot B will be 0. Okay, so this is wrong. So the only necessarily true statement is the choice in B. If A is a point with entries -2, 3 and B is 3, 1 and C is any other point on the plane, then which one of the following is the coordinate form of AC minus BC? So let us use this vector itself. AC, we are asked the coordinate form of AC minus BC. So to make things very simple, we know that minus BC is exactly the same as CB. Okay, we can use, in place of minus BC, we can use vector CB. So taking the vector itself, AC minus BC can be written as, this can be written as AC plus negative BC. Okay, in place of negative BC, we can substitute in place of minus BC, we can substitute CB. Okay, use CB. Now, using the principle of vector addition, AC, if I write AC like this and CB is like this, then AC plus CB will give AB. The resultant vector for this will be AB. It's very simple. So we have point A and B. AB means take the difference between the point B and A. B is the final, A is the initial. We subtract always the initial from the terminal. Now B is 3, 1 and A is -2, 3. So this means 3 minus of -2, 1 minus 3 will be the difference. 3 minus of -2 means 5. 1 minus 3 is -2. Therefore AC minus BC is 5, -2. This is the coordinate form for AC minus BC. So our answer will be B. A line given by the vector, a line given by a vector equation r of x is equals to 0, 3 plus t times 1, 1. This is a vector equation which is tangent to the circle at a point 0, 3. If the radius of the circle is radical 2, which one of the following is the center of the circle? So there is a certain line, which is tangent to the circle. So this line is given in vector form. So the point of tangency is also given. So the circle can be in this form. The circle can be in this side. Okay, maybe it is in this side. There are two possibilities for the circle, but let's take the information for the vector. The vector equation is r of x is equals to 0, 3 plus t 1, 1. This is the vector equation. So we have to convert this vector equation in some known form, or this vector equation can be written as x, y into 0, 3 plus t, t. Okay, this means 0, 3. We can add this thing. Therefore, this vector can be expressed as 0 with t is t, plus 3 with t is 3 plus t. This is x, y. Okay, so x becomes t. By comparison, x and t are the same. At the same time, y is 3 plus t. But here, x and t are the same, means I can use here x. So the value or y can be written as 3 plus x or x plus 3. X plus 3 is the equation of the line, or the vector equation of a line is given here. So our line is y is equals to x plus 3. And the radius of the circle is given. The radius of the circle is given. R is radical 2. Okay. So assume our center is given by HK. We want this HK. Okay. This HK can be here or can be here, whatever. But the point of tangency is 0, 3 is the point of tangency. So the equation of a line which is tangent to the circle is y is equals to x plus 3. Okay, so we have one fact: a line passing through the center and the point of tangency is perpendicular to the tangent line. Okay, so we know that the equation of the tangent line is y is equals to x plus 3. The slope of this tangent line is m is equals to 1. And the slope of the line passing through the center and the point of tangency should be minus 1. Okay, the slope of the line passing through the center and the point of tangency is minus 1. And this slope is also the same as k minus 3 over h minus 0. We can calculate the slope between 0, 3 and the center, which is minus 1. So from here, k minus 3 over h is minus 1. This implies k minus 3 is equals to minus h by crisscrossing. So k becomes 3 minus h. Take this as a single equation. Okay, use or call it, this is equation 1. Again, using distance between 2 points, r is the distance between the point of tangency and the center. R is square root of h minus 0 the whole square plus k minus 3 the whole square, and this r is radical 2. Now squaring both sides, h square plus k minus 3 the whole square is equals to 2. You can square it both sides. Okay, so in place of k, you can use the first equation. So this becomes h square plus k is 3 minus h minus 3 the whole square is equals to 2. This becomes 0. Then h square plus minus h square means h square is equals to 2. This implies 2h square is equals to 2. Dividing both sides by 2, h square becomes 1. So now h square is equals to 1 means h is equals to 1 or h is equals to minus 1. Now whenever h is 1, k becomes 2. Okay, in place of k you can use 3 minus h. Whenever h is 1, k becomes 2. Okay, or whenever h is minus 1, use here the first equation, k becomes 4. Okay, so the center will be either 1 comma 2 or minus 1 comma 4, because there are two possibilities for this circle. So we will search 1 comma 2 or minus 1 comma 4. 1 comma 2 is in our choice, so this can be the answer. What is the standard equation of the line passing through the point 2 comma 3 and parallel to the given line here, which is given in parametric form? So we are asked the standard equation of a line passing through 2 comma 3, which is parallel to the given line here, which is given in parametric form. So before proceeding to the determination of the line, we need to know something. If we have a certain vector equation of a line, which is given in this form, x comma y is equals to x naught comma y naught plus t times ab is the vector equation of a line where x naught comma y naught is a point in which the line passes, and the component a comma b is a direction vector. Okay, so here what is given, x naught comma y naught is given, which is 2 comma 3, in which the line passes. So we need to have the direction vector to completely determine the standard equation of the line. So let's keep this thing as it is. We do have this thing in which the line passes. So we need one more information, which is the parallel vector. We can obtain this thing from the another vector which is parallel to the given line. So this parametric equation of a line should be converted first. X is equals to 1 plus 2 lambda, and y is equals to minus 2 minus lambda is the same as, this can be written as x comma y is equals to 1 comma minus 2 plus lambda into 2 comma minus 1. Okay, this is the vector equation of the given parametric representation of the line. So from this we can see that the direction vector is 2 comma minus 1, which is parallel to the required line. So we can take this 2 comma minus 1 as AB. Okay, this can be considered as AB. Now we can determine the equation of the line. The equation of a line which is parallel to this line is x comma y is equals to x naught, which is 2, y naught is 3, okay, x naught comma y naught is given, plus t times the direction vector, which is a comma b. The direction vector is 2 comma minus 1. Now this is a vector representation of the line. So from here we can get the parametric equation of a line, 2 comma 3 plus 2t comma minus t. This is the same as 2 plus 2t comma 3 minus t. This is the vector equation. From this vector equation we can take out the parametric equation. X is equals to 2 plus 2t and y is 3 minus t. From this parametric equation we can get the standard equation. So from the first equation, t becomes x minus 2 over 2. This is the t value from the first equation. And from the second equation, t becomes y minus 3 over minus 1. Okay, these both are t. So from here we can get that x minus 2 over 2 and y minus 3 over minus 1 are both t. This equation is called the standard equation of the line passing through 2 comma 3, which is parallel to the given equation, which is expressed in parametric form. So the answer for this problem will be C. What is the equation of a line that passes through the point minus 1 comma 2 and parallel to the vector 1 comma minus 1? This is very simple, which is almost similar to the previous question number 7. So here we do have a certain line passing through the point, a certain point x naught y naught, which is 1 comma 2, and parallel to a certain vector v with component 1 comma minus 1. So if we do have these two information, we can determine the equation of a line, the vector equation of a line, by the formula x naught comma y naught plus t times ab, where this ab is the direction vector, x naught y naught is the point in which the line passes, t is any real number. Okay, so here we substitute everything. Here x naught y naught is the point in which the line passes, and AB is the direction vector which is parallel to the line. So this becomes minus 1 comma 2 plus t comma minus t. This is minus 1 plus t comma 2 minus t. So this is the equation of the line, the vector equation of a line. From here we can get x is minus 1 plus t, x is the same as minus 1 plus t, and y is 2 minus t, y is 2 minus t. This is called parametric equation of a line. Solving for t, from the first x is x plus 1 is t, and from the second equation y minus 2 over minus 1 is t. Okay, so this tells us the equation of the line. X plus 1 is equals to y minus 2 over minus 1, crisscross it, minus x minus 1 is equals to y minus 2. So this implies y is equals to minus x plus 1. or collecting like terms, this becomes x plus y minus 1 is equals to 0 is the equation of the line. So we will search this one or this one from the choice. So our answer will be B. Which of the following is a vector equation of the line? A vector equation of the line tangent to the circle x square plus y square plus 2x minus 7 is equals to 0 at the point of tangency 1, 2. We are asked the vector equation of a line tangent to the circle at this point. Okay, so assume this is our circle. Assume this is our circle. We center something. We can get the center from this standard equation. And the point of tangency of the line with circle is 1.2 is given. And now we are asked the vector equation of a line tangent to the given circle. So let us take the equations first. The equation of the circle is x squared plus y squared plus 2x minus 7 is equals to 0. This is the equation of the circle. We need to write this equation in standard form. So the standard form of writing a circle is a completing square meter. So x squared plus 2x plus y squared is equals to 7. So this means x squared plus 2x plus 1 plus y squared is equals to 7 plus 1. You can add the same amount of numbers on both sides. So this x squared plus 2x plus 1 means x plus 1 the whole square plus y squared is equals to 8. Now from this we get that the center of the circle is minus 1, 0. So minus 1, 0 is the center of the circle. We need this point. Then let's take a certain arbitrary point on the line. Say the point is x, y. Okay, so we can create a vector passing through this point and 1, 2. So let us construct a vector passing through these 2 points. Call it the vector passing through xy and 1, 2 is u, and again construct another vector passing through the center, a vector passing through the center and the point of tangency. So this is another line passing through the center and point of tangency. Assume this vector is v. We know that a line segment passing through the center and point of tangency is perpendicular with the tangent line. So we do have 2 vectors. One is u. U is a vector with initial point. You can make the initial point at xy and terminal at 1, 2. So u is a vector with entries 1 minus x, and the second entry is 2 minus y. This is vector u. And vector v is a vector whose initial point, you can make the initial point at the center and the terminal point at the point of tangency. Therefore it becomes 2, 2 is vector v. We know that u and v are perpendicular to each other. U and v are perpendicular to each other. So u dot v must be 0. If 2 vectors are perpendicular, their dot product is 0. That means 1 minus x, 2 minus y dot 2, 2 is 0. So calculating the dot product, it becomes 2 into 1 minus x plus 2 into 2 minus y is equals to 0. Now this means dividing both sides by 2, it gives 1 minus x plus 2 minus y is equals to 0. Okay, so x plus y, this implies x plus y is equals to 3, or y is equals to minus x plus 3 is the equation of the tangent line. Y is equals to minus x plus 3 is y is equals to minus x plus 3 is the equation of the tangent line. But the question is not this one. We are asked the vector equation of the line, this tangent line. So to calculate the vector equation of the line, so take x is equals to t. If x is t, then y becomes minus t plus 3, because y is minus x plus 3. So x is equals to t is also the same as 0 plus t, and y is minus t plus 3. So this implies our x comma y becomes 0 comma 3 plus minus, no, it's not minus t comma minus t, because x is 0 plus t and y is 3 minus t. Therefore, we can write like this. So this can also be written as 0 comma 3 plus t into 1 comma minus 1. This is the vector equation of a line which is tangent to the circle at the given point of tangency. So this is the required answer. So our answer will be C. If a point 25 is reflected under a line to the point minus 3 comma 1, what is the line of reflection? Here the point and its image is given. The point and its image is given. Roughly, suppose we have a certain line. Say this is line L, which is given by y is equals to mx plus b. Okay, then under this line of reflection, the point 2 comma 5 is reflected, and its image is given as minus 3 comma 1. So what is the line of reflection that gives the image minus 3 comma 1? So to get this line of reflection, the first thing is we construct a line passing through the given point and its image. Okay, so we construct a certain line. Say this line L is the line passing through the point, and its image is given by y is equals to m prime x plus b prime. To differentiate m with m prime, I have to use different notation. So it's very simple to calculate the line passing through the point 2, 5 and minus 3 comma 1. So let us do that. The first thing, we need to calculate the slope of the line m prime passing through 2, 5 and minus 3 comma 1. So this is the slope change in y over change in x. Our change in y is 5 minus 1 over 2 over 2 minus of minus 3. This is 4 over 2 plus 3, which is 4 over 5. The slope of a line passing through the point 2, 5 and minus 3 comma 1 is 4 over 5. We know that the line passing through the point 2, 5 and minus 3, 1 is perpendicular to the line of reflection. So m times m prime is minus 1. The product of their slope must be minus 1. So m prime is given 4 over 5 times m is minus 1. This implies m becomes minus 5 over 4. This m is the slope of the line of reflection. This is minus 5 over 4. So we do have the slope of the line of reflection. So we need one more point to completely determine the line of reflection. So this point is a midpoint. The point on L prime and L is a midpoint for the 2 points, for 2, 5 and for minus 3, 1. We do have a midpoint. So using midpoint formula, we add minus 3 with 2 and divide by 2. It becomes minus 1 over 2. And add 1 with 5 and divide by 2. The result is 3. Therefore, this is the midpoint for the point and its image. So this midpoint is on L and L prime. So we use this midpoint to determine y is equals to mx plus b. Y is equals to mx plus b is the line of reflection. M is already obtained. We can substitute the midpoint to find b. So let us do that. So y is equals to minus 5 over 4x plus b is the equation of the line of reflection. To get b, use y is equals to 3. 3 is equals to minus 5 over 4 times, in place of x, use minus 1 over 2. So minus 1 over 2 plus b. This becomes 3 is equals to 5 over 8 plus b. Now 3 minus 5 over 8 is the value of b. This means you can use crisscross. 24 minus 5 is 19 over 8. 19 over 8 is the value of b. So we substitute here. Okay, we will substitute here. Y is equals to minus 5 over 4x plus 19 over 8. Now multiply both sides by 8. It becomes 8y is equals to minus 10x plus 19. Or collecting like terms, this gives 8y plus 10x is equals to 19. This is the required equation of a line, which is assumed to be the line of reflection for the given point. So our answer will be C. If a translation T takes a certain circle x squared plus y squared minus 2x plus 6y plus 3 is equals to 0 into a circle whose equation is x plus 2 the square plus y minus 4 the square is equals to 7. Then what is the image of the origin under this translation T? So here we have two circles. This circle is obtained, the second circle is obtained by translating the first circle. So let us write both circles in standard form. Actually, the second one is written in standard form. So the original circle is x squared plus y squared minus 2x plus 6y plus 3 is equals to 0. This circle is translated to x plus 2 the whole square plus y minus 4 the whole square is equals to 7. So what is the translating vector that takes this circle into here? We need to know this thing. So let us write this circle in standard form first. The standard form is obtained using completing square method, x squared minus 2x plus y squared plus 6y is equals to minus 3. So this means x squared minus 2x plus 1 plus y squared plus 6y plus 9 is equals to minus 3 plus 1 plus 6. Plus 9. Okay. So this is the equation of the circle. The equation of the circle. So using completing square method, this part means x minus 1 the whole square plus, and this part is y plus 3 the whole square is equals to minus 3 plus 1 plus 9 is 7. Okay, so this circle is translated to this one by a certain translation vector. Okay, so the image of this circle under a certain translation is this one, meaning that the center of this circle, the center of the original circle is 3 comma minus 1, and the center of the image of the circle under a certain translation is minus 2 comma 4. So there is a certain translation. There is a certain translation that takes 1 into minus 2. That translation is minus 3. And minus 3 to 4 means 7. So the translation vector that takes this circle to this one is, the translation is minus 3 comma 7. So what will be the image of the origin under this translation? Okay, under this translation, the image of the origin will be minus 3 comma 7. So this is the required answer. So our answer will be A. What is the image of the ellipse given here under a certain translation that takes 1, 1 to 0, 2? Here, a certain translation is given. A certain translation is given. That translation takes the point 1, 1 to 0, 2. So definitely this translation must be minus 1 comma 1. The point, or you can take the difference. Okay, you can take the difference between 1, 1 and 0, 2. So this difference is minus 1 comma 1. So this is the translation. This is the translation that takes the point 1, 1 to 0, 2. Now the question is, what is the image of this ellipse? The image of this ellipse under a translation that takes this point, or under this translation, then followed by a reflection on the x-axis. So there are two things that we are going to do. First, we reflect it, we translate it, then we reflect on the x-axis. So the equation of the ellipse is x minus 1 the whole square plus 4y square is equals to 1. Okay, so under the given translation, this ellipse will have the image of this ellipse will be x squared plus 4 into y minus 1 the whole square is equals to 1. This is the image of the circle, the ellipse under the given translation. Okay, let's take this is 1. Now we reflect this ellipse, the ellipse x squared plus 4 into y minus 1 the whole square is equals to 1 will be reflected on the x-axis. Okay, what will be the image of this ellipse under the reflection on the x-axis? Normally this ellipse will have center at 0, 1. Okay, the image of this center under the reflection on the x-axis becomes 0, minus 1. The other thing is reflection is a rigid motion and a parallel movement, so everything will be preserved. So the equation of the ellipse with this center will be x squared plus 4 into y plus 1 the whole square is equals to 1. This one is the image of the given ellipse, which is obtained by translation followed by reflection. So our answer for this problem will be C. Okay, don't forget that we did two things at a time. We translate the given ellipse on this translation vector. Okay, then after we translate it, we get this one. Then this ellipse is reflected on the x-axis. Okay, reflection on the x-axis will gives us this ellipse. Okay, the image of a figure with vertices 1, 2, 3, 3, minus 1, 2, and minus 2, minus 2 after reflection across the x-axis is what? So here we are asked the image of a certain figure with the given vertices. Okay, so before finding the image, we need to know what the reflection on the x-axis looks like. For example, if we have a certain xy axis, if we have a certain xy plane, so whenever we have a certain point here with entries x, y, the image of this point under the reflection on the x-axis will be x, minus y. The only thing that changes is the second entry with change in sign. So take the point A. The point A is 1, 2. The image of this point A under the reflection on the x-axis is 1, minus 2. The second vertex B is 3, 6. Whenever we reflect this thing on the x-axis, the image will be 3, minus 6. The image of a point C with minus 1, 2 will be C prime with entries minus 1, minus 2. The only thing that changes is the second entry changing its sign. The image of the point D is minus 2, minus 2. This will have an image D prime with entries minus 2, 2. So these are the images of the point under the reflection on the x-axis. So from the given choice, 1, minus 2, 3, minus 6, 1, minus 2, 3, minus 6, minus 1, minus 2, minus 2, positive 2 is the choice in B. So our answer will be B. A line given by the vector equation, minus t, 6 plus 2t, where t is an element of real number, is tangent to a circle at a point 1, 4. What is the radius of a circle if its center is on the y-axis? There is a certain circle whose center is on the y-axis, and there is a certain line which is tangent to the circle at the point of tangency 1, 4. So roughly the geometric sketch of the given information looks like this. So there is a certain circle whose center is on the y-axis according to the information. If the center is on the y-axis, definitely the first entry will be 0 and the second entry will be k, and the point of tangency is 1, 4. 1, 4 is the point in which the line becomes tangent to the circle, and the equation of the circle is given by the vector equation of the circle is given by x, y is equals to minus t, 6 plus 2t. We need to express this in other form. This means x is equals to minus t, x is equals to minus t, and y is equals to 6 plus 2t, or 2t plus 6. So x is equals to minus t means t is minus x. Therefore, in place of t, we can substitute minus x. So y becomes minus 2x plus 6. So the equation of the line becomes y is equals to minus 2x plus 6 is the equation of the line which is tangent to the circle. So now we know that a line segment passing through the center and the point of tangency is always perpendicular to the tangent line. So we will determine the slope of a line passing through the center and the point of tangency. We know that the slope of this line, the tangent line, the slope of the tangent line is minus 2. Therefore, the slope of the line passing through the center and the point of tangency will be positive 1 over 2. So positive 1 over 2 is equals to the slope of the line passing through the center and the point of tangency. So change in y means 4 minus k over 1 minus 0, which is 4 minus k over 1. Okay, why we used the slope 1 over 2 for the line passing through the center and point of tangency? Because it's perpendicular to the tangent line. So from this we can get that 1 over 2 is equals to 4 minus k over 1. So using crisscross, 8 minus 2k becomes 1. This implies minus 2k is equals to minus 7. The value of k is 7 over 2. Now we have the center. The entries of the center will be 0, 7 over 2. Okay, this is the center. And we know that the point of tangency, at the point of tangency we have 1, 4. The question is the radius. That means the distance from the center to the point of tangency. This is the radius. So we apply distance formula between 2 points. So r is equals to square root of 1 minus 0 the whole square plus 7 over 2 minus 4 the whole square. So this becomes 1 square plus 7 minus 4 means minus 1 over 2, square it. Then this becomes 1 plus 1 over 4, which is radical 5 over 4. Now this 4 can be taken out from the radical. It becomes radical 5 over 2. So the radius of this circle will be radical 5 over 2, or half of radical 5. So our answer for this problem will be B. Let L be the line given by the vector equation x comma y is equals to minus 2 comma 1 plus lambda into 1 comma 1, where lambda is an element of real number. This is the vector equation of the line. Which one of the following is the image of this line after being translated by the vector u is equals to 2 comma minus 1 followed by the rotation through 45 degree about the origin? Here we need to be very careful in determining the solution of such problems. Okay, here what is given? The equation of the vector equation of the line is given, minus 2 comma 1 plus lambda into 1 comma 1, where lambda is an element of real number. This is the vector equation of the line. Now the question is, what will be the image of this line, after it has been translated by this vector followed by the rotation through 45 degree about the origin? So we are going to do two things at a time. Okay, First, we will translate it by the translation vector, by the given translation vector, and we will rotate through 45 degree about the origin. So to do this, we need to rewrite this this equation in the form of y is equals to mx plus b. Okay, it's good to write the given vector equation in this form so that we can immediately get the image. So let us convert this vector equation in the y is equals to mx plus b form. Y is equals to x comma y is equals to minus 2 comma 1 plus multiply this lambda by 1, it's lambda, by 1 it's lambda, then this becomes minus 2 plus lambda, 1 plus lambda is the vector equation. So from this we have x is equals to minus 2 plus lambda and y is equals to 1 plus lambda. Solving for lambda, we get x plus 2 is equals to lambda and y minus 1 is equals to y minus 1 is equals to lambda. Okay, so these two are lambda means y minus 1 and x plus 2 are the same. So this implies y is equals to x plus 3. Okay, y is equals to x plus 3 is the equation of the line which is here. Okay, this vector equation of a line and y is equals to mx plus b are the same. Okay, I did nothing except rewriting this in another form. This vector equation can be expressed in the form y is equals to x plus 3. Now we are going to find the image of the line y is equals to x plus 3. We will find the image of this this line by we will find the image of this line after it has been translated by 2 comma minus 1. Okay, we know that any x comma y can be converted by the translation vector 2 comma minus 1. We can convert this into x minus 2, y plus 1. Therefore, the translation, I mean the image of this y is equals to x plus 3 will be, so the image of y is equals to x plus 3, the image of this line under the translation vector 2 comma minus 1 is, it becomes this one, which is y is equals to x. Okay, you can rewrite this thing. This is y is equals to x. Now y is equals to x is the image of the line, y is equals to x plus 3 under the translation vector u is equals to 2 comma minus 1. Now again we will rotate y is equals to x. We will rotate this y is equals to x by 45 degree about the origin. Okay, now to find the image of y is equals to x under this rotation, we will take two arbitrary points on y is equals to x, 0 comma 0 and any point 1 comma 1 is a point. This is a point on y is equals to x. Okay, these are points. So we will rotate these points under through 45 about the origin. So to rotate these points, we need to remember the formula for rotation. So the rotation formula is x prime is equals to x cos theta minus y sin theta. This is rotation through angle theta about the origin, and x sin theta plus y cos theta. This is the rotation formula that we need to apply. So our theta is 45 degree. So the image of 0, 0 under this rotation is, Okay, in place of x and y, use 0, 0. So the image of 0, 0 under the rotation, under the given rotation is 0, 0 itself. By chance, you can use everywhere here 0, 0. Okay, so everything will be 0. And the image of 1, comma 1. Now, let's say x prime is the image. So x prime is equals to 1 times cos 45. Okay, use x1 and y1 in the given formula here. X prime is equals to 1 times cos 45 minus 1 times sine 45. Both sine 45 and cos 45 are the same. So the first entry will be 0. So here the first entry will be 0. And y prime is x times sine 45 plus y times cos 45. Both of them are the same, which is root 2 over 2. This is root 2 over 2. This is root 2 over 2. 1 times root 2 over 2 plus 1 times root 2 over 2 is radical 2. So y prime is radical 2. So here we have radical 2. Now the image of the line y is equals to x under the rotation of 45 degree about the origin. About the origin will give us 2 points, 0, 0 and 0, 1. So the line passing through these 2 points is a vertical line. It's a vertical line, which is x is equals to 0. Okay, because x is constant, therefore it is a vertical line. X is equals to 0. So this is the image of the line given here by the vector equation after the translation followed by the rotation. So x is equals to 0 will be the image. The last answer will be x is equals to 0. What is the image of the circle? X squared plus y squared minus 4x minus 6y plus 12 is equals to 0 when it is reflected with the line y is equals to minus x. So here we are asked the image of the given circle after it has been reflected on the line y is equals to minus x. So to do this, or to find the image of the given circle, we need first to write the equation of the circle in a standard form. So x squared plus y squared minus 4x minus 6y plus 12 is equals to 0 should be written in a standard form first. So to write this in a standard form, we use completing square method. So x squared minus 4x plus y squared minus 6y is equals to negative 12. So to apply completing square method, take half of minus 4 and square it. It becomes x squared minus 4x plus 4 plus y squared minus 6y. Take half of minus 6 and square it. It becomes plus 9. So here I added 4 and 9 on the left hand side. So I must do the same thing on both sides to maintain the equality. So this part, x minus 4x plus 4 means x squared, x minus 2 the whole square plus, and this part means y minus 3 the whole square, which is equals to the sum of all this thing, which is 3, which is 1. Okay, so this is the standard form of the given circle. Okay, these two circles are the same. So now we want to find the image of this circle, after it has been reflected by the line y is equals to minus x. We know that every point xy, the image of every point xy will be minus y minus x. the image of x comma y will be minus y comma minus x if the line of reflection is y is equals to minus x. So let's take the center of the given circle. The center of the given circle, the circle will be, the center of the given circle will be 2 comma 3. So it's enough to take the image of the center under the line of reflection y is equals to minus x. So it becomes minus 3 comma minus 2. Since reflection preserves the distance, the image of the circle will be minus 3 comma minus 2. So the image of the circle will be x plus 3 the whole square plus y plus 2 the whole square is equals to 1. This is the image of the circle after it has been reflected by the line y is equals to minus x. Therefore, from the given choice, our answer will be A. A is the answer for this problem. When the plane is rotated 45 degrees about the point 1 comma minus 2. When the plane is rotated 45 degrees about the point 1 comma minus 2, then what would be the image of the point 24 under this rotation? So here we do have a certain formula regarding the rotation of this kind. So the formula is here, if we have a certain point P, okay, when we have a rotation through an angle theta about the point x naught y naught, the image of the point P will be P prime with coordinates x prime y prime given by this formula. Okay, so the image of any point x comma y under a rotation of theta about the point x naught y naught is given by x prime y prime, where x prime is given here, and y prime is here. So we will apply this thing. So to write this thing properly, our x naught y naught is already given. X naught y naught is 1 comma minus 2. Okay, and theta is 45 degrees. Okay, we want the image of the point x comma y, where our x comma y is 2, 4. Okay, in place of x use 2, in place of y use 4. So using the formula, x prime is equals to x naught plus x minus x naught cos theta minus y naught sine theta. Here we substitute everything. So this means x naught is 1 plus x is 2 minus 1 cosine of 45 degree minus y is 4 and y naught is minus 2. 4 minus of minus 2 times sine 45 degree. Okay, so this becomes 1 plus root 2 over 2. This is 1 times root 2 over 2 minus 6 root 2 over 2. The result becomes 1 minus 5 root 2 over 2. So x prime becomes 1 minus 5 root 2 over 2. Now we need to determine y prime also. y prime is y naught plus x minus x naught times sine theta plus y minus y naught times cos theta. So we do have x naught, y naught, everything. So y naught is minus 2 plus x minus x naught is 1 times root 2 over 2 plus 6 times root 2 over 2. The result is minus 2 plus 7 root 2 over 2. Therefore, the image of the point 2, 4 under the rotation 45 degree, about 1 comma minus 2 is 1 minus 5 root 2 over 2 comma minus 2 plus 7 root 2 over 2. Therefore, our answer will be A.